Hello YouTube, today I'm showing you how you can calculate the output of your lithium polymer batteries. Each and every lithium polymer battery has 5 different types of ratings. The first one is a milliamperes, which is the capacity of the battery. The second rating is a C rating, we'll get into that later. It's pretty much the amount of discharge that gets outputted from the amperage. Next up, we got the amount of cells, also known as the amount of voltage. Then we have the continuous discharge and maximum discharge. We can use these 5 statistics to determine if one battery is better than another. So let's get into how we calculate this. The example I'm going to be using in this video is this Venom battery. The first number we need to determine is the amperage. The biggest number is usually the amount of milliamperes measured in milliamps, which is the capacity of the battery. If a battery has a larger capacity, it will have longer runtime in theory. Near it, you'll find a C rating. A C rating stands for the amount of discharge that the battery will output. There is a continuous discharge and a burst discharge. We will get more into that later. But for now, divide the milliamperes by 1,000 and times it by the continuous discharge to receive the amperage. Now that we have our amperage, we need to calculate the amount of watts. We determine the watts by multiplying the amperage and the voltage. But first we need to find the voltage. The battery is undoubtedly going to show a number next to an S symbol. The S means cells and the number next to it signifies how many. Every lithium polymer battery is composed of one or more cells. If each cell in a lithium polymer battery is fully charged, it will have 4.2 volts. Therefore, multiply the number of cells by 4.2 and you have voltage. Now we can determine the watts. Multiply the amperage and voltage to receive the watts. There you have it. The amount of watts is the output of the battery. We can use this number and compare it with other batteries to see which one is more powerful. But that's not the end of this. Remember in the beginning when I was talking about continuous discharges and burst discharges? Well, if you want to know the output of the battery when you're hitting full throttle, use the burst discharge in the equation rather than the continuous discharge. So in this video I was trying something way different. I just took advantage of things I could edit, and then I composed it to make something more interesting. I guess it was inspired by like other filmmakers like Casey Neistat and stuff like that. So if you're still confused about like what to calculate, here it is. So big number, 4,000. Crap, that's not 4,000. I'm just gonna do it with my right hand because that's way better. So 4,000 divided by 1,000 equals 4 amps. Then we're going to times it by 20 Cs, which will give us 80 amps. Now we multiply it by the voltage. Don't be confused with this. This is like the base voltage, I'd say, and you want the voltage when the battery is fully charged. So this is a 2-cell battery, 4.2 volts in each cell, so that would be 8.4. So we times it by 8.4. That was by 8. Anyways, I screwed up. You get the point. And you can also do it with the burst discharge. And on this battery, it says at the bottom there, you can't really focus on it, but it says max burst rate 30 Cs instead of 20 Cs. So it's going to naturally have 50% more power when you're hitting full throttle. And yeah, I know for a fact that this one is like, I kid you not, 3,000 watts. These are about 1,200 watts, and then yeah, these are my worst ones, but like, you know, it just gives a good comparison in between all of them. Anyways, yeah, hope you like this video, and I'll talk to you later. Peace out.